Right, let's get one thing straight. Building something tall is one thing, but building something tall? This is a whole different league. The story of the Burj Khalifa isn't just about concrete and steel, it's about pure, unadulterated ambition. It all started in Dubai, a city that decided it wouldn't just be on the world map, it would be the very center of it. The vision came right from the top, from Sheikh Mohammed bin Rashid Al Maktoum, the ruler of Dubai. He saw a future for the city that wasn't reliant on its dwindling oil reserves. He wanted to create an icon, a global landmark so powerful it would pivot the world's attention squarely onto this small patch of desert and announce, "We have arrived." The idea was simple but breathtakingly bold. Dubai needed a showstopper, a masterpiece that would become synonymous with the city itself, just as the Eiffel Tower is to Paris or the Empire State Building is to New York. The plan was to create a new downtown hub, a prestigious address that would attract international business, tourism, and investment. At the heart of this new district, downtown Dubai, would stand a tower so tall it would shatter every existing record. It wasn't just about being the tallest, it was about making a statement of intent, a declaration of what was possible when vision meets engineering and a colossal amount of willpower. This was to be the jewel in Dubai's crown. Imagine the meeting where this was first properly discussed. You're not just pitching a new office block, you're pitching a vertical city that scrapes the stratosphere. A project with challenges no one has ever fully tackled before. The scale is almost comical. The goal was to build a structure that would be a beacon of progress for the entire Middle East. It was named Burj Dubai during its construction, which simply means Dubai Tower. Its final name, Burj Khalifa, was a tribute to the leader of the neighboring emirate of Abu Dhabi, a nod to the support provided during its construction. It was more than a building, it was a national project, a symbol of pride, so the gauntlet was thrown down. The brief was simple: build the tallest freestanding structure in the world. Easy to say, unbelievably difficult to do. The project was handed to Emaar Properties, Dubai's premier real estate developer. They were tasked with turning this audacious dream into a shimmering reality of glass and metal. The world looked on, some with skepticism, others with awe. Could it really be done? Could a city built on sand really raise a tower that would touch the heavens? Dubai was betting its reputation, and a massive pile of cash, that it absolutely could. The stage was set for the greatest construction story ever told. Now you don't just sketch the world's tallest building on the back of a napkin. The design for the Burj Khalifa had to be revolutionary. The job went to the American architectural firm Skidmore, Owings and Merrill, with the legendary Adrian Smith as the chief architect. What they came up with wasn't just beautiful, it was incredibly clever. The design is inspired by the Hymenacalis flower, also known as the spider lily, a regional desert plant. If you look at the tower from above, you can see the shape, a central core with 3 wings or petals branching off it. This isn't just for looks, oh no, this is genius engineering. This buttressed core design is the secret to the Burj Khalifa's stability. Each of the 3 wings supports the others, creating an incredibly strong and rigid structure. As the tower rises, the wings step back in a spiral pattern. This clever spiraling shape does something brilliant. It confuses the wind. Wind is the ultimate enemy of a super-tall skyscraper. A steady wind can create vortices or mini whirlpools of air that cause the building to sway dangerously. By constantly changing the building's shape as it goes up, the Burj Khalifa's design ensures that no single organized wind pattern can ever get a proper grip. It's a masterclass in aerodynamics. Of course, a project this massive needs a serious amount of money. We're talking billions. The developer, Emaar Properties, secured the initial funding through a combination of its own capital and by pre-selling the residential and commercial units within the tower before it was even finished. Imagine buying a flat in a building that doesn't exist yet, one that promises to be higher than anything ever built. It was a huge vote of confidence. However, the project was launched just before the 2008 global financial crisis hit, which put immense pressure on the finances. This is where the spirit of collaboration came in. In the end, the project's completion was secured with financial support from Abu Dhabi, Dubai's wealthy neighbor. This is why, at its grand opening ceremony in 2010, the tower was renamed from Burj Dubai to Burj Khalifa, in honor of Sheikh Khalifa bin Zayed Al Nahyan, the president of the UAE and ruler of Abu Dhabi. It was a gesture of gratitude for the crucial support that helped push the project over the finish line. The final cost? A cool $1.5 billion. A staggering sum, but for a one-of-a-kind global icon, many would argue it was a price worth paying. With the design sorted and the money in place, it was time to break ground. But you can't just stick a half-mile-high tower on top of sand. The foundation is everything. The engineers had to dig deep, really deep. They drilled down over 50 meters into the ground to find suitable bedrock. They then installed 192 massive concrete piles, each one 1.5 meters in diameter. These piles act like the roots of a giant tree, anchoring the building firmly to the earth. On top of these piles, they poured a colossal concrete and steel mat foundation that is nearly 4 meters thick. It's a monster of a base, built to hold up a monster of a building. Now for the clever part, the concrete. You can't use just any old concrete for a project like this. It needed to be incredibly strong to support the immense weight of the tower, but also workable enough to be pumped to record-breaking heights. And here's the kicker, it had to be poured in the scorching Dubai heat, which can cause concrete to set too quickly. The solution? They mixed the concrete with ice and often poured it at night when the temperatures were cooler. This gave them enough time to get it into place before it hardened, ensuring maximum strength and integrity throughout the structure. It was a simple solution to a massive problem. Getting that concrete up to the top floors was a feat in itself. The team used a series of powerful pumps, some of the strongest ever made, to push the liquid concrete upwards through pipes. They set a new world record by pumping concrete to a height of over 600 meters. That's nearly 2,000 feet. Imagine forcing a thick, heavy sludge that high against the pull of gravity. It's like trying to drink a milkshake through a straw that's a quarter of a mile long. This had never been done before, and it required specially designed pumps and concrete mixes to make it happen. The central core of the building, made from this high-performance concrete, is what gives the Burj its spine. As the concrete core grew, the steel structure for the upper floors followed. The very top of the Burj Khalifa, its famous spire, is made of lighter structural steel. This spire alone is over 200 meters tall, a skyscraper in its own right. It was assembled in sections inside the building and then jacked up into its final position using a powerful hydraulic system. This combination of a super strong reinforced concrete core for the lower two-thirds and a lighter steel frame for the top third was the perfect recipe for building a stable, lightweight, and record-breakingly tall structure. It was a symphony of materials, all working together to defy gravity. Once you have the skeleton of your giant, you need to give it a skin. For the Burj Khalifa, this meant fitting over 26,000 individually cut glass panels. This isn't just any glass, mind you. This is high-tech super performance glass. Remember, this building sits in the middle of the desert where daytime temperatures can be brutal. The building's exterior, or cladding, had to be able to reflect the intense solar heat to keep the inside cool, while still being transparent enough to offer those billion-dollar views. It also had to be strong enough to withstand high winds and the occasional sandstorm. A very big ask. The solution was a special type of reflective, low-emissivity glass. Each panel is made of 2 panes of glass with a layer of air in between. The outer pane has a thin metal coating that reflects solar radiation, basically bouncing the sun's heat away. The inner pane has a different coating that reflects heat from inside the building back in, which is useful during cooler nights. This double whammy of technology massively reduces the amount of energy needed to cool the building, which is a huge deal in a place like Dubai. The panels were designed to be incredibly durable, tested against wind, water, heat, and structural pressures. Putting these panels on was a monumental task. The panels were manufactured and cut to precise sizes with over 200 different shapes and sizes needed to fit the tower's complex, spiraling design. A team of specialist engineers and installers worked their way up the building floor by floor, fitting these panels into an aluminum frame. This process took years to complete. They used a series of custom-built machines and cradles that moved up and down the building's exterior on tracks. It was a slow, meticulous process, requiring incredible precision at dizzying heights. One wrong measurement, one slipped panel, and the whole system could be compromised. And they didn't just have to be good, they had to be clean. Keeping the windows of the world's tallest building sparkling is a job in itself. The Burj Khalifa has 18 permanently installed building maintenance units, or BMUs. These are basically sophisticated window cleaning machines. They are hidden away in garages within the building structure when not in use. When it's time for a wash, these machines, carrying a team of cleaners in a cradle, emerge and travel along tracks on the building's facade. It takes a team about 3 to 4 months to clean the entire exterior from top to bottom. And by the time they finish, it's time to start all over again. You can't build a skyscraper without cranes, and for the world's tallest skyscraper, you need the world's best cranes. The Burj Khalifa was built using a trio of massive tower cranes, each one capable of lifting enormous loads of steel and glass, and equipment to staggering heights. These weren't just parked at the bottom, these cranes were attached to the building itself. They were the workhorses of the project, operating day and night to keep the construction schedule on track. As the building grew taller, the cranes had to grow with it. This is where a bit of engineering magic comes in. The cranes used a process called self-climbing or jacking. As the building's concrete core rose, the crane would lift itself up to a higher level. A special climbing frame would be installed around the crane's mast. Powerful hydraulics would then push the entire crane upwards, section by section. Once it was high enough, new mast sections would be inserted underneath it by another crane, and the whole thing would be secured to the building's core at the new, higher position. This leapfrogging process allowed the cranes to effectively climb the building as it was being built, always staying just ahead of the construction work. One of the three main cranes was positioned on the central core, while the other two were on the wings. For over 4 years, these machines lifted thousands of tons of material. The crane operators were a special breed, working in a tiny cab hundreds of meters in the air, with nothing but a pane of glass between them and the ground. Their precision was vital. They had to place heavy steel beams and delicate glass panels with millimeter accuracy, all while battling the winds that whip around the tower at that altitude. It was one of the most demanding and high-stakes jobs on the entire site. But this leads to a brilliant puzzle. How do you get the cranes down? The two wing cranes were dismantled by the top central crane. It would lower the pieces of the other cranes down to the ground, section by section. Simple enough. But then you're left with one crane at the very top of the world's tallest building. The solution was ingenious. A smaller recovery crane was assembled on the roof. This smaller crane then dismantled the main crane, lowering its parts to the ground. Then an even smaller crane was brought up to dismantle the recovery crane. This continued until all that was left was a small derrick crane that could be taken apart by hand and brought down in the service lift. Problem solved. A structure as grand as the Burj Khalifa is not built by machines alone, it is built by people. At the peak of construction, more than 12,000 workers were on site every single day. That's the population of a small town, all focused on a single goal. These workers came from all over the world, a true legion of builders from over 100 different countries. The majority were skilled and unskilled laborers from South Asia, from countries like India, Pakistan, Bangladesh, and Nepal, who came to Dubai seeking work and the chance to be part of something truly historic. They were the hands that mixed the concrete, tied the steel, and fitted the glass. The logistics of managing such a diverse and enormous workforce were mind-boggling. The project was a 24/7 operation, with teams working in shifts around the clock to keep the construction moving forward. Special accommodation camps were built to house the thousands of workers, with transport organized to ferry them to and from the site each day. The project management team had to coordinate not just the construction tasks, but also the catering, safety protocols, and daily lives of this multinational community. It was a massive human undertaking, a testament to what can be achieved when people from different cultures and backgrounds unite for a common purpose. Working conditions were, without a doubt, challenging. The intense heat of the Dubai summer was a constant danger, with temperatures often soaring above 45 degrees Celsius. To combat this, safety measures were put in place, such as shifting working hours to the cooler parts of the day and night during the peak of summer, and ensuring constant access to water and shade. Building a super-tall skyscraper is inherently risky work, and the safety of every single person on site was the highest priority. The project involved a staggering 22 million man-hours to complete, a number that reflects the immense human effort poured into its creation. The legacy of the Burj Khalifa therefore belongs as much to these thousands of workers as it does to the architects and engineers. While the headlines often focus on the records and the design, it's crucial to remember the sheer human power that made it possible. Every single bolt that was tightened, every pane of glass that was polished, and every floor that was poured represents a day's hard work by someone, often hundreds of meters in the air, far from their home and family. The finished tower is a silent tribute to this global army of craftsmen and laborers who, quite literally, raised a city to the sky. So you've built it, it's up. Now, how do you make it livable? A building this tall is basically a vertical city, and it needs its own life support systems. Let's start with water. Getting water up to the 160th floor is a serious plumbing challenge. You can't just use one massive pump. The pressure would be so immense it would burst every pipe at the bottom. Instead, the Burj Khalifa uses a series of water tanks located on different mechanical floors throughout the building. A pump sends water up to a tank on, say, the 40th floor. A second pump then takes it from there to a tank on the 70th and so on, all the way to the top. It's a relay race for water. Then there's the air conditioning. In Dubai, AC isn't a luxury, it's essential. But cooling a 5.7 million square foot building is an epic task. The system is one of the largest cooling plants ever built for a building. It uses a clever system where chilled water is circulated through pipes all over the tower to cool the air. And here's a cool fact, at the very top of the tower, the air outside is significantly cooler than at the bottom. The AC system actually draws in this cooler, cleaner air from the upper floors to help ventilate the building, saving a huge amount of energy. It's like the building is breathing through its head. But the most critical system for a skyscraper is its lifts, or, as our American friends call them, elevators. What's the point of having a penthouse on the 154th floor if it takes you an hour to get there? The Burj Khalifa has 57 of them, and they are some of the fastest and most advanced in the world. The main service and observatory lifts are double-deckers and travel at a blistering 10 meters per second. That's about 36 kilometers per hour. You can get from the ground floor to the observation deck on the 124th floor in about a minute. To manage traffic, the building uses a sky lobby system. Express lifts whisk people up to these lobbies, where they can then switch to local lifts that serve a specific block of floors. Safety is paramount, especially in an emergency. The building is designed with multiple pressurized, air-conditioned refuge areas located every 25 to 30 floors. In the event of a fire or other emergency, people can shelter in these safe rooms until help arrives. The lifts are also part of the evacuation plan, a first for a skyscraper of this height. Specially protected lifts can be used by emergency services to evacuate people quickly and safely. Every system from the water and air to the lifts and lighting has been engineered with redundancy and safety as the top priorities, making this vertical city not just spectacular but also secure. When you build something as extreme as the Burj Khalifa, you don't just break one world record, you absolutely obliterate a whole bunch of them. It's the undisputed champion of tall things. First and foremost, at 828 meters, it's the tallest building in the world, by a long shot. It's also the tallest freestanding structure, snatching the title from the CN Tower in Toronto. It has the highest number of stories in the world, over 160, the highest occupied floor, and the highest outdoor observation deck at the top sky, on the 148th floor. It even has the world's highest swimming pool, on the 76th floor. The list just keeps going. The lift with the longest travel distance in the world, that's in the Burj. The tallest service lift in the world? Yep, that too. The construction itself set records, like the highest vertical concrete pumping we talked about earlier. The sheer amount of materials used is mind-boggling. The aluminium used on the exterior weighs as much as 5 A380 Super Jumbo jets. The concrete used weighs as much as 100,000 elephants. And if you were to lay out all the steel rebar used in the structure end to end, it would stretch over a quarter of the way around the entire planet. It's just bonkers. Of course, a building this famous is bound to attract a few urban myths. One of the most common ones is that the building's sewage is taken away by trucks because it isn't connected to the municipal wastewater system. This is a great story, but it's not true. The Burj Khalifa is fully connected to Dubai's main sewer system. The rumor probably started because, during the frantic construction boom in Dubai, some new developments did temporarily use tankers while the infrastructure caught up, but the flagship tower itself was properly plumbed in from day one. It's a myth that just won't go away. Another popular fib is that the tower sways so much at the top that you can get seasick. While all tall buildings are designed to sway a little bit in the wind, it's much safer than being completely rigid. The Burj Khalifa is incredibly stable. The movement at the very top is only about 1.5 meters from side to side, even in strong winds. This happens so slowly, and over such a massive height, that it's completely imperceptible to the people inside. The engineering is so good, you could have a full glass of water on a table on the top floor and not see a single ripple. So, what is the final verdict on the Burj Khalifa? It is, without a shadow of a doubt, one of the greatest engineering achievements in human history. It's more than just a tall building. It represents a fundamental shift in what we thought was possible. It took the rulebook for skyscraper construction and completely rewrote it. The project tackled immense challenges, from building on sand and pumping concrete to record heights, to cladding a building in the desert sun and managing wind forces no one had dealt with before, and it solved every single one with groundbreaking innovation. The solutions developed for the Burj Khalifa have set new standards for the industry. The buttressed core design, the advanced wind engineering techniques, the high-performance concrete mixes, and the self-climbing crane strategies are now all part of the toolkit for architects and engineers dreaming up the next generation of super-tall structures. It proved that with the right combination of vision, technology, and international collaboration, the physical limits of construction can be pushed further than ever imagined. It was a giant real-world laboratory for high-rise engineering. The Burj Khalifa achieved exactly what it set out to do. It put Dubai firmly on the global stage, transforming its image and becoming an instant, internationally recognized icon. It's a magnet for tourism and a symbol of the region's ambition and forward-thinking attitude. It proved that a city could build its way to global fame. But its importance goes beyond just one city. It stands as a powerful symbol of human ingenuity, a testament to our relentless desire to reach higher, build bigger, and push the boundaries of what is possible. It's a message of optimism cast in steel and glass. Ultimately, the Burj Khalifa is a landmark of the 21st century. It's a demonstration that even in an age of digital wonders, our ability to create astonishing physical structures remains one of our most powerful and inspiring talents. It has changed skylines and mindsets, becoming the benchmark against which all future megastructures will be measured. For now, it remains the king of the clouds, a shining beacon that reminds us all to look up and wonder what incredible feat of engineering we might achieve next. Absolutely brilliant. Absolutely.